Our next speaker, Craig Gressbrink, has been a solutions architect at 24 Hour Fitness for 8 years and the product owner of the Cash team for the last year and a half. His extensive experience as an Oracle PL SQL programmer, Java programmer analyst, and solutions architect. He holds a bachelor's of computer science and an MBA from San Diego State. Please welcome Craig.
Thank you. Today we're going to be talking about fitness, the grid, and the future, and how they all tie together. At least, so we're going to go through 24-hour fitness use cases. But first, who is 24-hour fitness? 24-hour fitness, we have about 430 clubs across 13 states in the United States. I'm guessing most of you are in California. About 250 of those clubs are in California, so I suspect if you're in California, you're definitely aware of 24-hour fitness. We have nearly 4 million gym members that we service with about 22,000 employees, a lot of them in-club or part-time. So here's the question, and I still get asked this today, and I still get asked this by people at my company. So the goal of this is to explain and give some context of where we're using it and why we're using it. And I did want to mention that I did do a longer presentation yesterday in a little more detail, so if you find this interesting and want to know some of the gory details on how we did it when the slides become available, that was yesterday at 11 a.m. Before I get into any of the use cases, I just wanted to talk about this simple 3-tier architecture because most of the diagrams that show the use case talk about this. But we usually have applications or user interface tiers that call web services, could be REST or SOAP from our ESB. I collapsed it here, but our data services tier is like a CRUD tier that basically it also exposes web services that the ESB calls and queries databases or queries the grid and puts data into the grid or databases. So I'm giving a bit of our journey going back 5 years on how we got started with in-memory computing. Our first use case is, there's the slides. Our first use case was someone would come into our application online, self-service, our website, and make a payment. And it would say, go and look at our ERP tables, our base tables, and it would say you owed $50. They would make a payment, and then you can see on the bottom where it says the batch runs every 6 hours. If they happen to come up or bring up their smartphone within 5 hours, maybe on the way to the club, it would read those same base tables and it would come back and say, you still owe $50. And that confused some people. They expected more from us. And not a whole lot, but some amount of people made a second payment. That created a member services nightmare. Now they started calling and we had to go clean it up. And before I know people are thinking, well, why aren't your pages, didn't you just put on there? It could take as much as 24 hours to process your payment. We did. People don't read that. They expect real-time data. So that was our first foray. We decided to put in our accounting services tier, a middle layer tier, a distributed cache between the JVMs. And how that works, essentially, the get balance is exactly the same. On the initial call, it would find that you owed $50. You would go in and make a payment. At the time you make a payment, we would populate a recent invoice payment received cache that we store for about 12 hours, or we can adjust the time if we want, depending on how often that batch is running and how consistently it's running. But essentially, if you would come back 4 hours later, it will do the same thing, query the base tables. The batch hasn't run yet. You'll still owe $50, but on the way out, it'll say, I see that you owe $50 for invoice 123, but I also see that you paid invoice 123 within the last $6, just subtracts $50. Nothing real complicated there, but that's how we got started. And the distributed part is keeping multiple JVMs in sync, giving the same answer. So that's the benefit of a distributed cache. Then we went in and replaced our on-prem HR system, and the question was, about 4 years ago, do we put another on-prem system in? Do we go cloud or SaaS? We chose SaaS, and I was kind of a SaaS evangelist, and like, this is a good idea. And my thought back then was, this is great, we don't even need a database. The SaaS providers should provide us APIs that are performant, fast, and we can call as often as we want. And why would we store our employee data when we can call their APIs and get the data? This is perfect. So it wasn't exactly nirvana. What happened in this scenario was the SaaS providers' APIs were not guaranteed to be up 24/7. We're a 24/7 business. We like making sales online whenever you want to buy from us. And so to support that and not give the wrong impression to the business, or basically just to support 24/7 sales and not be down, we chose to cache the employee data so we always had access to it. And so you can see we do change detection every 5 minutes. We use the SaaS providers' APIs, we put it all in our grid, and then we always query from the grid. And that's proved very successful. And it's not as if this HR systems APIs are really down 2 hours every week, but contractually they were allowed to take it down for maintenance as much as 2 hours per week. And like I said, we just had to protect the business. Then we went in and said, we had a homegrown lead management system, no CRM system, and we said, same question, should we build it or buy it? We chose to buy it, and we went with a leading CRM system in the cloud. And I was still pretty naive. I might still be naive, but less naive. And I thought, well, this is good. Surely that was a fluke. Their APIs will allow us to create leads and get data from them whenever we want to support our applications. No need to store any of that data on-prem. So what really happened is, and this is a little bit of a summary, but I thought you would make one API call to them to create a lead. But really what they do in our app, we take in that you're from California on our form, but when their create lead listed as number 5 there, it wanted the GUID for California. That is different from our dev, QA, train, and prod systems. So we chose to do something pretty simple, which is, I guess I should go to what we actually did. We chose to store at startup all of those GUIDs for both states, what club, you have to translate our club numbers to a GUID, and then about 8 other things it wants GUIDs instead of the actual human readable thing. So we load those at startup, and then we simply pass in those human readable things, get back the GUIDs, and now you can see we are making one API call. And that's important because their API, so the chatty part is the multiple API calls we would have had to do to translate one by one their GUIDs, whereas we don't have to do that here. And then their APIs weren't particularly quick, and when you have 10 calls to it and it's slow, that's 10 times as slow. So that's been very helpful. And then the big one, most of my talk yesterday was regarding this. We replaced our on-prem ERP with a leading class SaaS billing system. We've been doing that for about the last year and a half. Again, we would have hoped it would have worked like this diagram. We'd create a subscription from our apps, and we would be able to call their APIs, figure out if they owed us money, what subscription they have, should we let them in the club, should we ask them for payment at the front desk at the club. We can search them up. But what really happened is number 3.1 down there on the bottom right, as soon as we went in and you come to the front desk and we try to look you up with your first and last name, it wasn't able to do like searches with the SaaS vendors' APIs. So enter the grid. So we decided to take, on the bottom right, every 15 minutes we call the SaaS vendors' APIs. We get all of their billing data, member account subscriptions, their charges, their invoices, their payments, the exact object model from our billing system we store as caches in the grid, and every 15 minutes it's Delta data, and then you can see we query the grid now, and that helps us get around API rate limits. The biggest reason I thought we needed the grid, if you listen to my 2017 presentation here, was that we are definitely going to hit the API rate limits of this SaaS vendor. We never did because we implemented this approach, so all queries are going against the grid, and only when we need to write data, insert, or update data do we go and use the SaaS billing APIs. Another use case where this has worked out well for us, all the data is now in the grid, and that includes how much they owe us and those kinds of things. So if we look at our member check-in app or our club check-in app, the way we did it in the past was basically running through all 4 million members, figuring out if they owed us money every single night so that tomorrow our check-in app could tell the front desk people, hey, please collect money. So it's not real time. It's kind of like the other use case, and we never solved for that. If you made a payment in the morning but came in to work out in the afternoon, the front desk would tell you, you owe us money. But now, with all of that data in the grid, with all that data in the grid, we query real time, near real time, because we're 15-minute delayed from getting the data from our SaaS billing system, but that's a lot better than 23 and a half hours delayed. We query all the tables in their raw form and then determine to our check-in app, do you owe us money? Do you have access to this club? Do you have a personal training session? Is it your birthday today? Should we wish you a happy birthday? All of that is operating on the raw data caches. Why is that important? It's not summarized, and once benefit of a data grid is you have all the data in there. Any new business use cases that come up, we have all the data in the grid, and it's very simple for the developers to write a query and go ahead and implement that new use case. I mean, it could be as simple as who are all the customers who purchased, or you check in the front desk. Certainly if you have a personal training session today, we'll let you know, but it could be you've purchased personal training sessions in the last week, but you haven't scheduled them. That's something else where it's our opportunity to try to talk with the customer as they're visiting the club and make that happen to support our business. We have, with this implementation, the other implementation summarized everybody to one row in a disk-based database, and with even running these complex queries against the object models, we're finding faster response times come with an in-memory grid doing that than we did hitting a one-row table from a traditional disk-based system. Oops, wrong one. So we talked about reasons why you might use an in-memory data grid real quick. Cloud and SaaS vendors' APIs might have limitations that don't support your business. Almost all of them have rate limits so that no one customer can monopolize their system. So be on the lookout for, do you think your business is going to overutilize their APIs and you're going to hit the rate limits? If you are, maybe not using up your rate limits to do queries is a good solution. Again, they could be slow and chatty. Maybe they're not guaranteed to be up. Of course, I say if you're a SaaS vendor, they have to be up 24/7. To me, that's a definition of a SaaS vendor. But some of the cloud systems, that's not the case. You may not be able to support searches, the kind of queries you want to do against the data that's sitting in your SaaS system. And another example I didn't really talk about is a lot of the SaaS APIs are kind of object-based. Get me the member, get me the subscription, get me this. You're getting one object at a time. You can't really join the data together, and that can affect your application development. It can affect your ability to debug the state of, for us, a member account or a customer. What's the state of them? You have to kind of run it all and sort of as a human, put it all together. So another reason is you want fast, scalable, near real time, and you want a future-proof. You want your solution to be future-proof. That might be another reason to use an in-memory data grid versus traditional database. How fast is it? Well, let's see. Before we do that, we've started going live with the 2-club pilot in August, and now as of last week, I'm proud to announce all 430 clubs are every sale, every member check-in, and every member service transaction for these 1.5 million member accounts is going through the grid, and every new sale is being created in the grid. But probably the biggest thing on here, and so we don't have a lot of data. A year from now, especially like we have 9 million invoice items, that's going to grow to 20 million in a year. We've only been live for half a year and we migrated people over little by little. That 1.5 million was 1.2 million about 2 weeks ago. So we're steadily migrating over to get, by the end of the year, to get all 4 million into the new system. So we're looking at a graph here. This up on top, it's get subscriptions, and it's showing you how fast our data service, if you remember the other diagram, our APM solution, our application performance monitoring solution, is timing it from the time the web service gets called to the time the web service responds. And the web service is using the Ignite Thick client to do a SQL query against the grid. And we're seeing that queries that are tuned properly are about 3 seconds. Nothing's over 10 milliseconds. If anything is over 10 milliseconds, we're doing full table scans. We need to create indexes and tune our queries. More on that in my previous talk. I won't get into that. So now we're talking about the future and other benefits. Some people say, well, maybe we didn't need that 3.5 millisecond response time. Maybe a second for each API call would have been good enough. It may have been. Our SLAs are not that tight in most cases. Our member check-in app is probably the exception because people don't like to stand in line. They don't like to wait when they come to work out. And you put your thing down and even 2 seconds, you're just kind of like, come on, I came here to work out. So I started thinking about what is digital transformation. I'm kind of a lifer at 24-Hour Fitness. I've been there 19 years, an architect for 8, and I've been the product owner of the grid or the cache team for the last year and a half. But yeah, I'm kind of a lifer. So started thinking, back in 2000, we had a commissioned sales force. We no longer have a commissioned sales force. But back then, we started, it was .coms and websites, and we started selling memberships on the web. And the rub was, for the people in club, you're taking away my commissions, and you're selling on the web. So for me, that was really when digital transformation started. I know it's a new term. It started slow. But the point of this slide is to show that we're evolving, and then I'll make a case of why the grid is a future-proof solution. Like I said, in 2001 to 10, we had websites, and so maybe you started creating APIs then, maybe you didn't. But then you started getting smartphones, and you stared realizing, oh, we got a mobile app and a web app, and everybody's kind of doing the same thing, and our employees need to do some of the same things. So APIs become big. The volume of calls to APIs increases. Certainly for us, when we do a marketing campaign, now that we have a mobile app, if we actually, it's a little bit of a hack, but I'm hopeful the grid can help with this, and I'll tie back to that later, but we tend to stagger our 4 million members. We don't give you an email blast and have all 4 million hit our APIs because our old systems wouldn't handle that. We tend to go, 100,000 every hour because we're basically spacing it out. Makes it kind of hard to do a 4-hour flash sale if you want to announce it the morning of, so there's definitely limitations to that. But you know, in 2017 or so, maybe 16, we started having Alexa, Google Home. We haven't done it yet, but I'm hopeful we get to the point where you're taking a shower, getting ready, brushing your teeth in the morning, and you're saying, hey, what's the Group X class schedule for my club at 24-Hour Fitness? So you can hear when the times are, and oh, well, maybe I'll decide to go do, you know, I got ready a little early, maybe I'll go do that Group X class or that aerobics class in the morning. So all of these things are going to be, and then we have what's coming, right? We got VUIs, cars. The best example I can think of is my buddy and I were doing Lyft and Uber, but we didn't do it last night, or the night before. We were waiting for the hotel shuttle. And we're like, why didn't we call Uber? We should have done Uber or Lyft. At least I can see how long it waits. So we're standing there waiting. God, it would be real nice if they told me how long it would take for the shuttle to get there. And so we're having that conversation. And then I see out in the hotel, it looks like they have that. They have a board up there that tells you when the hotel shuttle will be here. Not only that, you can see the arrivals at the airport. All of these people are expecting information whenever they want it. I'm sure if I had the app, I could pull it up. So my point of this is, over time, the amount of calls to your API has probably increased, and I have no reason to believe that they're going to decrease. I think they're going to be called more and more as people expect things. You got arrivals out there. You're going to have IoT devices using your API. So if you're in that situation, maybe just meeting today's SLAs are not good enough. I just threw this in real quick just to kind of makes the point, but just that data volumes are getting bigger, the amount of data, the type of data to support certain use cases. I would expect in our grid more data to come in from different data sources to support those use cases. And then just that people are expecting real time. We're no longer batch. It's kind of frowned upon, and there's no reason to think that's not going to continue as well. So I guess, is it your turn? Do you see any use cases that you might do within memory? Maybe everybody here is already doing it, Maybe some of these use cases will give you an example of something else you can do with in-memory, but why not make it happen? This took a lot of work. You may have to evangelize and socialize your idea and explain over and over again why this is a better solution than a traditional database. You might have to do vendor and product evaluations, and you might even have to do contract negotiations. So once you do that, you're going to own the product and the solutions you evangelize in good times and bad. We went through some struggles, but we're doing pretty good right now. We're continuing to tune to get ready for our Q1 and busy season. But the short of it is, to make it happen at your company, you may have to step out of your comfort zone. So I would encourage you to challenge yourself and enjoy the journey. Thank you very much.